Bohr was the first to explain quantitatively the general features of the structure of the hydrogen atoms and its spectrum. He used the Planck's concept of quantization of energy, whatever I discussed in the previous class. Bohr's model of hydrogen atom is based on the 4 postulates. Number 1, the electron in the hydrogen atom, you know that only electron in the hydrogen atom, only 1 electron in hydrogen atom. And it can move around the nucleus in a circular path of fixed radius and energy. And this path is called the orbits or stationary states or allowed energy states. These orbits are arranged concentrically around the nucleus. You can see this figure. These all are orbits, and it has the circular path from where the electron will move. Electron, the only electron for the hydrogen atom, it will move here. But when it will be excited, then it will go to the next orbit having more energy levels. Second postulate, the energy of electron in the orbit does not change with time. When it will move with this orbit, the electron, there is no change of the energy with time. However, the electron will move from a lower stationary state. It is the lower stationary states. And when it will move to the upper or higher stationary state, when required amount of energy is absorbed, then the electron needs energy to absorb to go to the higher level orbit or higher stationary state. And reverse also possible, when from the higher energized orbit or stationary state, it come back to the lower stationary state in this way, green color you can see, and then it will release the energy. And the equation is delta E is equal to EF minus EI. That means that energy difference will be energy in the final state minus energy in the initial state. So when it will go from the lower stationary state to higher energy state, like this red arrow, then final stationary state EF is positive more than the initial energy of the initial state. So that is the EI. So obviously the delta E will be the positive when the electron will move from the lower energized stationary state to the higher energized stationary state. The energy change does not take place in a continuous manner. It will not take a continuous manner. We'll see with the help of the Planck's theory. So postulate number 3, the frequency of radiation absorbed or emitted when transition occurs between two stationary states that differ in energy by delta E, and it is given by this delta E is the E2 minus E1. If it is immediate higher stationary state, then it will consider the E2 and immediate lower energy state, this will consider as a E1. So in this case, the frequency is equal to delta E by H. H is the Planck constant, whatever we explained in our previous class. Then ultimately this frequency will be E2 minus E1 by small h. Then the E1 and E2 are the energies of the lower and immediate higher allowed energy state respectively. And this expression is called the Bohr's frequency rule. So what is the Bohr's frequency rule? What is the expression of that? Then we will write the frequency is equal to E2 minus E1 by small h, where the h is the Planck's constant and E1 and E2 is the energy of the lower and immediately higher energy state. Now, fourth postulate, the angular momentum. The angular momentum already I discussed in the previous class number 023. The angular momentum of an electron is quantized, and in a given station state it can be expressed as in equation. This equation, this is the angular momentum, where the m is the mass of the electron, v is the velocity, and r is the radius of the orbit in which the electron is moving. So MEV here is equal to, because it is quantized, so n dot h by 2 pi as per Planck's theory. And this has h by 2 pi has a fixed value, as a constant value, because h is the constant and pi also constant. Then n is the whole number 1, 2, 3. So n is the whole number and it is 1, 2, 3. So obviously this MEVR, what is the expression for the angular momentum? It will be quantized. That means any value it will be unable to take, only related n dot h by 2 pi, where n is equal to 1, 2, 3, only that value it will take. And this is called the angular momentum of an electron is quantized. So it is written there clearly, an electron can move only in those orbits for which its angular momentum is integral multiple. Integral multiple means when n is equal to 1, 2, 3, 4, in that way, integral multiple of h by 2 pi. And whatever just now I told, that means the angular momentum is quantized. So the radiation is emitted or absorbed only when transition of electron take place from one quantized value of angular momentum to the another quantized value of angular momentum. So now, according to the Bohr's theory for the hydrogen atom, whatever we understood from this postulate, the station states from electron is numbered, n is equal to 1, 2, 3. Here you can see that every orbit is called as 1, 2, 3, 4. And it was designated also with the, when the n is equal to 1, this is the K shell. When n is equal to 2, it is the L shell, capital K, capital L. And when n is equal to 3, it is the capital M shell. And when is the n is equal to 4, it is called the capital N shell. And in center, the positive charge nucleus is there. And this integral number is called the principal quantum numbers. So question comes that what is the principal quantum numbers? Then you can write in this way: the stationary states for electrons is numbered from the ground state to upper state 1, 2, 3, 4, and this is called the quantum numbers. Number B, the radius of stationary states. These all are the radius. This is radius for the n is equal to 1. This is the radius for the n is equal to 2. This is the radius n is equal to 3. And this is the radius when the n is equal to 4. So in this case, the radius we can calculate using this formula. Rn, when n is a subscript, Rn is equal to n square A0, where the A0 is the 52.9 picometer. This is the experimental value. So when n is equal to 1, this means first case, this is the radius. This radius value is the 52.9 picometer. And for normally for the hydrogen atom, only this orbit is available, n is equal to 1, and when the n increases, that means 2, 3, 4, 4, in that way the R value also will increase according to this equation. In other words, the electron will be present away from the nucleus. That means when the electron is away from the nucleus, then its radius also will increase as per this equation. Now point number C. The most important property associated with the electron is the energy of its stationary state, and it is given by the expression. This equation is put by the Rydberg equation, whatever we explained previously during the explanation of the electromagnetic radiation. So En is equal to minus RH multiplied by 1 by n square, where n is equal to 1, 2, 3. And this RH is called the Rydberg constant, and its value is constant 2.18 multiplied by 10 to the power minus 18 joule. So the energy of the lower state means when n is equal to 1, then this n in this equation will replace by the 1 in this calculation. Then E1 ultimately its value will be the minus 2.18 multiplied by 10 to the power minus 18 J. Here one question will come that why the minus is there. That I will discuss in the end of the class. And again when the energy it will consider for the n is equal to 2. That means the second orbit, in that case the E2, if you n replaced by the 2 in the equation, then it will be the minus 0.545 multiplied 10 to the power minus 18 joule. So in this way we can calculate the energy of the stationary state using this equation. En is equal to minus RH multiplied 1 by n square. RH means the Rydberg constant for hydrogen. We have to mention it. Now here you can see that these all equations, it is evident that the value of energy becomes more negative and that of the radius becomes smaller with increase of the atomic numbers Z. This means that electron will be tightly bound to the nucleus. And point number E, it is also possible to calculate the velocities of electrons moving in these orbits. Although the precise equation is not given here qualitatively, the magnitude of velocity of electron increases with the increase of the positive charge on the nucleus and decreases with increase the principal number. That means when the nucleus is positive charge is increased, then the electron's velocity will increase. And another factor, when the electron away from the nucleus, that means when the principal quantum number is increased, then the magnitude of velocity of electrons on the nucleus will decrease. So here same equation you can see here, and here you see that what does the negative electronic energy for the hydrogen atom means. So here it is written there clearly. It has been taken from the NCERT books, and here the point we have to discuss, that the negative sign means the energy of the electron in the atom is lower than the energy of a free electron at rest. That means free electron means it is far away from the nucleus. A free electron, when it is at rest, is an electron that is infinitely far away from the nucleus and is assigned the energy value of 0. So mathematically, this corresponds to by setting the n equal to the infinity in the equation, and then in this calculation, if you put this is the infinity, then ultimately E is equal to 0. Here if you put the infinity, then ultimately this value will come 0. As the electron get closer to the nucleus, that means when n is decreases, then En become the larger in absolute value. And in this case, it is more negative. That is from infinity, when it will come closer to the nucleus, then the En becomes larger in the absolute value and more negative. The most negative energy value is given by the n is equal to 1, which corresponds to the most stable orbit. And this we call the ground state.